I am so excited about some of what I'm learning about thermal conductivity based off of what you guys are saying, and it's causing me to second guess myself and go do some research, and I'm learning a ton, and it's really cool. I want to talk about thermal conductivity, and I'm going to try as hard as I can to keep this short and sweet. And one thing I'm learning about myself is that I don't do that very well. Okay. So thermal conductivity is caused by the vibration of molecules. Now, this I already knew, but basically within any sort of material, you have these little molecules of, this is cork, of cork that are just moving back and forth. And the faster that those molecules are moving, the hotter that material will be. Now, this is a really easy thing to kind of understand. If you just put your hands together and you rub them, you'll feel your hands getting hot. And that's just the friction of your hands rubbing against each other. Now, in a material, you just have these molecules that are buzzing against each other. They're buzzing and they're hitting each other, and that is what gives something a warmer temperature. And the faster that it's moving, the more thermal energy that it will have. This is also related to how large this object is. If I just have a tiny piece of cork, that's going to have less thermal energy than if I have a big piece of cork, because it's going to take more energy to change that object's temperature. Okay. So I want to talk about aluminum, because that was, obviously in your conclusions, just answer after answer saying, I had aluminum, it was a conductor, aluminum, it was a conductor, aluminum, it was a conductor. And then one person said, I had aluminum in there, but that's an insulator. And that kind of took me aback, and my first instinct was to immediately be like, you're wrong. But I did a little bit of research online, and I found, and it might have just been like Google questions or something like that said, oh yeah, it's an insulator. And so that made me wonder, and I tried to justify, does that make sense? And I think the easy way to justify that is to say that overwhelmingly your coolers worked, and almost all of you guys used aluminum. Not everybody, but a lot of people used aluminum, and everybody's cooler, at least to some extent, prevented ice from melting. Okay, so I thought I was done, right? I'm okay, all right. Turns out that aluminum is a thermal insulator, even though it conducts electricity, so it's an electrical conductor. But then, as I'm just kind of thinking about this, I'm like, that still doesn't make sense. Most materials that conduct electricity also conduct thermal energy. So electricity is the free movement of electrons from one place to another, and thermal conductivity is this vibration of molecules, or of the atoms in there. All right, so here's my thought process that's going on is, why would it be that all of these different, that so many different kinds of metals are thermal conductors, but aluminum isn't? And what I understand about aluminum is that if I have some bread in the oven, I can reach into there with my bare hand and grab the aluminum and pull it out, and my hand doesn't burn. Well, that doesn't make sense, because that aluminum has been in the oven, and the oven's at 400 degrees. Why would I be able to reach it unless that aluminum was, the word is dissipating, but the aluminum is letting go of its thermal energy very rapidly as I open up the oven. So here's the answer. Aluminum is a conductor. It is a thermal conductor. In fact, it works incredibly well. It's one of the best. The reason that it kept your ice from melting is that you weren't touching your ice to the aluminum. So the aluminum was hanging out on top. Here's your ice cube, here's the aluminum, and it was blocking the sun. So, it basically was reflecting the sun away from your ice cube. basically, if you put anything over your ice cube and put your ice cube into the shade, it's going to do better than one that's hanging out in the sun. I mean, I don't think you guys could argue with me about that. But the aluminum still actually did better than a different kind of material. And here's what I've understood. Here's what I've researched and understood as to why. The aluminum, it does a really, really fantastic job. In fact, metals do a really fantastic job of transferring heat if two objects are touching. But if the objects aren't touching, if there's a space in between, then the metal itself might heat up, but it's not going to transfer it through that air very well at all. So here's an application, and I just think that the best way to do this would just be to read it to you. And this is from a website. I guess I'll just link the website down here. Okay, for example, consider that you have just cooked a turkey and want to keep it warm. By surrounding the turkey with a heat shield, you can prevent the heat from escaping and stop the turkey from getting cold. The best way to do this is to get a solid sheet of aluminum foil and wrap it around the turkey, being careful to ensure that there's a small gap of air between the turkey and the foil. The foil will reflect the thermal radiation back into the turkey, will block thermal convection currents, and the air gap will ensure that the metal does not thermally conduct away heat. I know those are some really big words there, but essentially what's happening is that if the aluminum foil is actually touching the turkey, then it's going to radiate. Is that the right word there? No, conduct. So it's going to thermally conduct that heat away. But if you have a little gap in between, which I haven't ever thought of doing that, but if you loosely wrap your turkey in aluminum foil and have an air pocket there, then your turkey will heat up the air around it and then just hold on to, and the aluminum will allow it to retain that heat, which is an incredible application of thermal conductivity, something that you can immediately go use in your everyday life. Another one that I was thinking of, and this is where my brain just goes, is if you're going into a sauna, like one of those hot, steamy rooms, and if you were wearing jewelry. So metals are really good thermal conductors. Well, so I remember once going in and I had like a silver necklace on, and I actually felt my skin getting warm, like getting hot, and so I took it off. Well, I think you can seriously burn yourself if you're wearing jewelry, metal jewelry, in a hot place, because it can conduct that thermal energy just directly onto your skin. There are lots of things like this. I mean, you can think about playground slides, but this video is 8 minutes and I need to shut up. So anyway, I thought that was really cool. And if you've watched this far, it's because you're fascinated about this as well, or really bored. I hope it's the former. Okay, bye.